When fresh motor oil goes into an engine, it looks clean and carefully formulated. Thousands of kilometers later, that same oil comes out dark, contaminated, and filled with soot, microscopic metal particles, traces of fuel, moisture, and other substances it collected while protecting the engine. Most people look at that black liquid and see waste. But what if the part that looks worthless is actually the part worth recovering? Because used motor oil hasn't simply been destroyed. Much of the valuable base oil can still remain inside it. The real problem is that this oil is now mixed with everything the engine has added to it. And that changes the question completely. It isn't simply a question of disposal. It's a question of separation. Inside a running engine, motor oil has a difficult job. It reduces friction between moving metal surfaces, carries heat away from critical components, keeps microscopic contaminants suspended, and protects engine parts while operating under high temperatures, pressure, and constant mechanical stress. But every kilometer adds another challenge. Normal engine wear creates tiny metal particles that become suspended in the lubricant. Combustion produces soot and other residues, while dust, moisture, and traces of fuel can gradually enter the oil. At the same time, the additives that help control oxidation, deposits, and other unwanted reactions slowly degrade. Eventually, the oil can no longer provide the protection the engine needs, which is why it has to be replaced. But notice what actually happened. The oil did not simply become worthless. Valuable base oil became mixed with substances that no longer belong in it. So how do engineers separate what is still valuable from everything that has contaminated it? That question wasn't always understood. In the early days of automobiles, used engine oil was often dumped onto roads for dust control, burned as low-grade fuel, or simply discarded because its long-term environmental effects were not fully understood. As automobile ownership expanded, the amount of used oil increased dramatically, and so did the consequences of careless disposal. Used oil released onto land can penetrate soil and potentially threaten groundwater. When it reaches waterways, it can spread across the surface and interfere with oxygen exchange, creating harmful conditions for aquatic life. By the 1960s and 1970s, stronger environmental regulations encouraged proper collection and recycling, while engineers were also discovering something important: lubricating oil does not necessarily lose all of its value after one use. Much of the underlying base oil can still be recovered. And that realization changed the entire approach. Instead of asking, "How do we get rid of this dirty liquid?" engineers could ask, "How do we recover what is still useful?" The answer begins long before the oil reaches a refinery. Used motor oil comes from passenger cars, trucks, motorcycles, boats, industrial machinery, repair shops, dealerships, and service centers. It is collected and stored in sealed containers or tanks, then transported by specialized vehicles to recycling or re-refining facilities. But the engineers can't simply treat every batch in exactly the same way. Two containers of used oil may look almost identical while containing very different amounts of water, fuel residues, antifreeze, solvents, and other contaminants. So before serious processing begins, technicians analyze the incoming oil to determine what is actually inside it. Once the composition is understood, the first cleaning stages begin. Heating removes water and lighter fuel components, while filtration captures larger contaminants such as dirt, rust, and metal fragments. But the oil is still far from finished. Some contaminants are too small for ordinary filtration, while others are mixed into the oil itself. Removing them requires a different approach, and this is where one of the most important stages of the process begins: vacuum distillation. Under normal atmospheric pressure, separating heavier oil fractions would require very high temperatures. But excessive heat can damage the valuable material engineers are trying to recover. So instead of simply adding more heat, engineers reduce the pressure. Inside a vacuum distillation system, the lower pressure allows different components to separate at lower temperatures. Useful oil fractions can be recovered while reducing the thermal stress on the material. It's a simple but powerful engineering idea. When more heat creates a problem, change the conditions instead of simply adding more energy. But even after distillation, the recovered oil can still contain chemical impurities. That's where hydrotreating comes in. The oil is processed with hydrogen under controlled temperature and pressure, helping remove unwanted compounds containing sulfur, nitrogen, oxygen, and other impurities. The goal isn't simply to make the oil look clean. It is to improve the chemical quality of the recovered base oil so it can meet the demanding requirements of modern lubricants. And now the transformation becomes clear. What entered the facility as dark, contaminated used oil has been collected, tested, separated, purified, and chemically treated. But purified base oil still isn't finished motor oil. Modern lubricants are carefully engineered formulations, so fresh performance additives can be blended into the recovered base oil to provide the properties required for its intended application. At that point, material that once looked like nothing more than dirty waste can become useful lubricant again. But not every batch follows exactly the same path. Some used oil may not be economically suitable for complete re-refining because of its contamination level or the processing required. Even then, it may still contain useful energy. Depending on the material and applicable regulations, processed used oil can be used as industrial fuel in facilities such as cement kilns, asphalt plants, steel mills, or other systems equipped with appropriate emissions controls. So the goal isn't necessarily to turn every drop back into exactly the same product. The broader goal is to recover as much useful material or energy as possible while minimizing environmental impact. And that matters because careless disposal can turn a recoverable resource into an environmental problem. Proper collection keeps used oil inside a controlled industrial system, where valuable material can be recovered instead of being released into soil or waterways. There is another important advantage. Re-refining allows industry to recover base oil that has already been produced rather than relying entirely on new crude petroleum to create fresh lubricating oil. Recovering and purifying existing material can require significantly less energy than producing equivalent lubricating oil from crude petroleum. So an ordinary oil change connects something surprisingly large: mechanical engineering, industrial processing, resource recovery, and environmental protection. But perhaps the most interesting lesson isn't about motor oil at all. It's about how engineers define waste. We often assume that when something has finished its original job, its value has disappeared with it. But engineering asks a different question. What has actually been lost, and what is still recoverable? In used motor oil, the answer is surprisingly clear. The lubricant has changed. Its additives have degraded, contaminants have accumulated, and it can no longer perform its original job reliably inside an engine. But the valuable base material can still remain. That's why its appearance is so misleading. The black color tells you that the oil has been through thousands of kilometers of heat, friction, combustion, and contamination. It does not tell you that every useful part of the material has been destroyed. And once you understand that, an ordinary oil change starts to look completely different. The liquid draining from an engine isn't simply something being thrown away. It is a complex mixture containing both unwanted contamination and material that can still have value. With the right collection system and the right engineering, that mixture can be tested, separated, purified, treated, and transformed into something useful again. The engine may have finished with the oil. The material itself may not be finished at all. That is why used motor oil isn't actually waste. If you want more stories about the hidden engineering behind the ordinary things around us, subscribe to VIRESIA, and tell us in the comments which machine, vehicle, or everyday technology we should investigate next.